Hello and welcome back. In this lesson, I'm going to show you some of these points, the differences between GUI and CLI programs, setting preferences, how to view and use the disassembler window pane, what are entry points, and some of the basic commands to step over the programs line by line. Okay, let's get started. Now, if you go back and look at the place where you download this CrackMe, it is stated by the author, which is Evil Programmer, and that this is a very easy flag. What do you mean by flag? Flag is a kind of password. You can also view it as a serial number, which you are supposed to find from the program. Now, let's take a look at the program which we downloaded here. If you were to double click and run it, it will just open and close very briefly. So this shows that it is a command line interface program which you need to use run from the command prompt. So you need to open the command prompt and run it. So that gives us the first example of the differences between GUI and CLI programs. GUI programs are graphical user interface programs, which are those programs which have a window and a mouse. It can be used to click to run or terminate the program. CLI programs are command line interface programs such as this. So when we first start to learn about software cracking, we would like to keep things simple and learn how to crack command line interface programs first. And then later on, we can move to the graphical user interface. So this Mexican CrackMe is a command line interface program. So to run the program, we need to open a command line prompt. Let me show you how to do that. So you click on the bottom left corner, right click on it, and look for command prompt. And then you open the command prompt. And then you should navigate to this location of the CrackMe. So you can type cd c : / followed by this. You can type it all out manually like this, or an easier way is to simply type cd and then from here copy the path and then here right click and paste and then press enter. Immediately you enter the correct folder that contains your CrackMe. So now to run it from the command line prompt, first you must list the content of this directory by typing dir and enter, and you will see the name of your CrackMe, which is called untitled1.exe. Now to run the program from the command line, you will do something like this. You will type the name of the program. You don't have to spell it out in full. You can just type UN and press the tab key on your keyboard and it will complete the name for you. Now you just have to press enter to run it. And you can see an output say try harder. Okay, so this is what it shows you that you need to find a way to get hold of the flag, the serial number or the password or whatever you might like to call it. So among hacking circles and cracking groups, this trying to find out the serial number or the password or some secret phrase is called capture the flag, CTF in short, CTF. So this cracking activity is something like trying to capture the flag as well. So that's why this author says it's a very easy capture the flag. So at the moment this program is teasing you, asking you to try harder. So okay, now I will show you how to capture the flag. So what we're going to do is firstly analyze this program, which I have shown you how to do in the previous lessons. That is to open it with DIE. So when you open with DIE, it will show you the entry point and the image base. So this is a hint to tell you where does the program start to run. And what are these numbers? These numbers are memory addresses. Okay, let me close this and show you. So now we are going to open this crackme using the x64dbg. So we drag it and drop it here and run. Okay, so now as the moment you open this program, you can see it's already started, but it is paused there. And it is paused at this entry point. This is not an entry point, by the way. This is the starting of the operating system. This is not yet your program. You haven't even entered your program yet. You are in the operating system. So how do I know that? Because earlier on, when we analyzed the program by opening it with DIE, DIE showed us that the entry point is at this location. Image base is at this location. So an image base is the address where your program starts, but it is not the entry point. To get the entry point, you must take this number, which is in hexadecimal, add to this number, the image base, and that will give you your entry point. So your entry point should be 004014E0. That is your entry point. Okay, and from here we can reach our entry point. I'll show you how to do it. But first things first, we need to set some preferences for our x64dbg. So to set the preferences, we go to options on top here, click on preferences, and we want to uncheck this TIS callbacks. Well, there is no need to know what this means because it only gets more confusing, but trust me, you don't want to have this checked. So for all your cracking projects, make sure this is unchecked. And normally you only have to do this once and it will remain unchecked. So just uncheck this. The second thing you want to do is go to the exception tab. So this is events tab. Now go to exceptions tab, and here you are going to add a range of exceptions. And what are exceptions? Exceptions are errors that arise in the program. Now x64dbg is able to handle any errors that arise. It is a debugger after all. But for cracking software purposes, we want to throw the error back to the program. So we are going to tell x64dbg to ignore all errors so that the program will handle it and we can analyze its behavior better. So we have to add these exceptions in here. So click on add range. Now exceptions range from the numbers 0, 0, 0, 0, 0, 0, 0, 0. There are 8 zeros there and ends with 8 Fs. F, 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 that's 4. F, 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 8 Fs. So just click OK and you should have this. So this means that you want your x64 debugger to ignore all these errors and throw it back to the running program to handle it so that we can observe its behavior. So now just click save and we are all set. So now you can see the program paused at this operating system address. So let me explain to you what all this means. Now the first column is known as the address in RAM, memory. The second column is your code in binary form, written as hex numbers. If these numbers are actually in 10, 10, 10 and so on, but to make the number shorter, we put it in hexadecimal form. So these are actually known as opcodes or machine codes. Opcodes. So for the most part, we are just going to ignore these opcodes. And then in the third column is your interpretation of these opcodes in human readable form. So this human readable form is what we call assembly language, and that is where we get the name disassembler from. This program x64dbg is a disassembler because it disassembles the machine code into human readable form called assembly code. So from opcode or machine code to assembly code or assembly program. And this is what we are looking at most of the time because this is human readable. So the third column and the fourth column here is the comment column. The comment column sometimes is populated by strings like this. You can see the comment. These comments are inserted helpfully by x64dbg, and it makes our job much easier because the x64dbg has interpreted some of the meaning of these weird symbols and show it to us here, and we'll be making use of this quite a lot as we go along. Now there's one more column which I've omitted, which is over here, and this is something like a graph. So this graph here try to map how the instructions are jumping from one location to another. For example, you see this instruction will jump from here to here. That's the meaning of jump, JE. All these instructions starting with J means to jump, and there are many of them. You can see here, jump here, and then here's another jump. All those things starting with J means jump. Okay, I'll explain that in greater detail later. Okay, so this is how you interpret the disassembly window or disassembly view. Okay, so now we are whenever you start a program, it always starts in the operating system over here. And if you want to restart the program, you just click on this button, restart, and it will restart all over again at the operating system. Now we are in operating system, we are not yet in this entry point. Your entry point is the entry point for your crack me itself. So we do not want to crack the operating system, we want to crack the crack me itself. So we have to go to this image address location. So remember, this is address, so we have to go to 040014EO. So to go there, there is a shortcut way to go to it directly. That is by clicking this button, run, or pressing F9 on the keyboard will do the same thing. So you click this now or press F9 and immediately watch the address. As I click on this, it goes straight to the entry point. So this entry point is supposed to be your entry point for your program. Alright, 4014E0. Okay, so that we are correct. So we start at entry point 4014E0 and you can compare it with DIE. Take this number, add to this, and you get this number, 4014E0. So this is how you can know where is your entry point supposed to be. And to go there, all you need to do is restart the program, click this one time, and it will land on your entry point. Sometimes this command does not show entry point here. So sometimes this might just be a blank. So if this is a blank, if you want to confirm whether this is really the correct entry point, always refer back to DIE. DIE, detect it easy, will show you the entry point. You just take this hex number, add to this, and you get this entry point. Okay, so that is how we launch our program and enter the entry point. Alright, so the next thing I want to show you is how do we step through all these instructions. So to step through the instructions, we will press the F8 key on the keyboard, or you can click this key, this button, which means step over. So F8 key is to step over. F9 is to run. What is the difference? If you click this button, run, or press F9, it will run and end the program. That means it will go through the program without stopping, and your program has terminated. As you can see on the bottom left corner, terminated, debugging stop. So we don't want to press F9 all the time. That's why we need to press F8 after pressing F9 to hit our entry point. So let's try again. Restart. Now we are restarting. We want to go to the entry point. What do? We press F9 on the keyboard or click on this button, run, and we land in the entry point. Okay, so now we want to step through line by line. We should press F8 or this button. So we keep pressing F8 or we click on this button, it will move from one instruction to the other in sequence from top to bottom. Sometimes it may jump all over the place. Let's take a look. Okay, this call will go to this address 402.680 and then come back and continue here. Okay, so it will actually go to that address and come back here. Again, let's step over. Keep on pressing F8. Alright, now we come to our jump. Remember, I mentioned earlier, all those instructions starting with J are jump instructions, and there are two types of instructions that jump. One is conditional, the other is unconditional. This instruction is a conditional jump, and this instruction JMP is unconditional jump. What is the difference? Conditional jump will depend on the test just above it. So based on the result of this test, it is testing two registers over here, is testing something, and based on the result of the test, it will decide whether to jump or not to jump. An unconditional jump does not depend on any test, it will jump straight away. That is the meaning of unconditional jump. So now we are here, as you can see. Let's continue to step over it, pressing F8. So now it is at this point, and how do we know whether it will jump or not? How do we know? We can look at this. You look at this status box here, and it says jump is not taken. That means it will not jump. And another indication that it will not jump is, look at this line. If it is going to jump, this line will turn red. This line indicates the jump. Look, it is a long jump, right to the bottom somewhere, but we are not going to go there now. So it is not going to jump. Alright, so this is confirms it as well, it is not going to jump. So if you press F8, it will just go to the next line without jumping. Watch. So I press F8 or click this. True enough, it goes to the next line. And I keep on pressing F8, see what happens. F8, 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 F8. Okay, so now you notice this line turns red, meaning that this jump will be taken because this turns red. Another confirmation is here. Jump is taken. Notice? So this is called an unconditional jump. It does not depend on any test above before it. So now just press F8 and see it jump. And even tells you where it is going to jump to. It is going to jump to this location 401.216. Here 401.216. You can see there are two arrows, one here and another arrow here. So this column tries to draw a better graphical view of the jumps. Here is a simplified arrow to show you the jumps. And you notice the arrow can be pointing down and some arrows are pointing up. This means jump upwards. This means jump downward. So the direction of the arrow tells you where it will jump. It will jump. Now this kind of upward jumps are normally loops that keep on looping for a certain period of a certain number of times. Alright, so now we are here and we are going to jump unconditionally. And this word in front here is the name of your program, which is untitled 1. So normally the x64dbg will put your program name in front, put a dot, followed by the address where it will jump to. Okay, so now if you press F8, it's going to jump all the way down to 401.2016 as mentioned here. So let's do it now and see what happens. See the jump. True enough, so it has taken a jump. So now we press F8 again and it keep on going. Now let's analyze this now. Press F8. Okay, is it going to jump or not? What do you think? Yes, I think you will have got it correct. It is not going to jump because firstly, this line did not turn red. Now remember, this is upward jump. It didn't turn red, so it is not going to jump. Another indication is over here. Jump is not taken, indicating that it is not going to jump. Alright, we can confirm it by pressing F8 and it should move to the next line below. F8, and true enough, it moved to the next line below. Let's continue pressing F8. F8, F8, F8. Now what do you think? Is it going to jump? Yes, it is not going to jump. Why? It didn't turn red. The line didn't turn red. And the indication here says jump is not taken. So press F8. Yes, this one will jump because it turned red and the indication shows jump is taken. So let's press F. So where is it going to jump to? It is going to jump to 401.481. So it's going to jump way below down here. 401.481. Right? Okay. Now I already scroll down with my mouse. How do I go back to the last location? Very easy. See EIP, click on it, and you go back to the last place where you stop. So EIP is called an instruction pointer. The E in front means extended instruction pointer. All the E in front means extended. So EIP. Whenever you're lost, let's say I scroll all the way down and I want to go back to my last indication where I stopped, I just double click this and I go back here. Now I can continue stepping. So when I press F8, it will jump all the way to 401.481. Let's do it. See, it landed here. So now I press F8 again and it continues to go like this. Now what is the difference between call and jump? Call also does a jump, but it doesn't show you. If you want to see jump, you need to press another key, but I will show that to you in another lesson. For now, I just want to introduce you to jumps. What are jumps? So we'll do call in another lesson. So now let's press F8. Okay, so it jumped here. F8 again. This one will jump because it turned red and here says jump is taken. Call, jump, jump. So it jump here. So all of the assembly code is just about jumping and calling. That's it. Jumping and calling. Call, 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 call. Jump. No jump taken. Alright, fine. F8. Jump. Okay, so this is going upwards. F8. It didn't jump because the arrow didn't turn red. Okay, this will jump upwards. It turned red. And here also says jump is taken. So it jumps up. Up again. So this is a loop. So it will keep looping until a certain condition is met. Okay, so you can keep on pressing and pressing F8, 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 and eventually it will terminate the loop. And where do you think it terminates the loop? where do you think the loop will terminate? You can keep on pressing and keep trying. Okay, this is one way you terminate a loop. You will go out of the loop up here. Alright, so that is one way. Or you can just press F8 and hold. You press F8 on the keyboard and hold, and it will go faster. Eventually, you leave the loop. Once you leave the loop, release the key F8. Now I'm holding F8 on. Okay, it has come out of the loop. And now it is somewhere else. Okay, so now it is over here, and the jump is not taken. So press F8 again, and you can see it keeps on going. So this is how you step through the code. Okay, so eventually, if you keep on pressing F8, you will reach the point where the message "try harder" will be shown here. But you might miss it if you keep on pressing and releasing, and you missed it. You see that? Because we're already pressing F8 without releasing, so it missed it. So in the next lesson, I will show you a way in which you can pause the program using breakpoints. So that's all for this video. I'll see you in the next one. Thank you for watching.